over the entire lab so that you can see it. Just a couple things I want to highlight is there's going to be 14 test tubes that's going to have all of your data. So test tube 1 is going to start over here and then go to 14. So this will be test tube 14. And then I number them up here so you can see what each one stands for. All right, so starting off, let's just read the objectives. This is measure the effects of changes in temperature, pH, and enzyme concentration on reaction rates of the enzyme. Explain how environmental factors affect the rate of enzyme catalyzed reactions. So what we're looking at, the focus of this, if you look on your paper, is it says the reaction. What we're looking at is 2H2O, which is hydrogen peroxide. That's, you put it on your cuts and it bubbles. You ever used peroxide before? Okay. Now, that breaks down, all right, to produce, you can see on the other side of the reaction, that arrow, it says 2 water molecules and oxygen. So what we're focused on is the oxygen being produced, and that's going to be the presence of bubbles, which is what we're going to be looking for. So when it talks about rate the reaction, I think it gives you the numbers from 1 to 5, 5 being it's really vigorous and intense, and 1 being not much is happening, okay? So we're going to establish a control first. So what we're going to do is in test tube number 1, I'm going to put in 2 milliliters of peroxide, all right, into beaker number, or it's your test tube number 1. And we're going to observe what happens when we put liver in there. Now liver is very high, this is liver right here, in an enzyme called catalase, which breaks down peroxide, okay? Just a little piece of liver, and we're going to put it in our test tube. And observe what happens. Right? So yeah, it's breaking down the peroxide and producing oxygen, all right, and water. So water's still in the test tube, and the oxygen that's being released, all right, where's it going to go? It's the only places you got. What gas is being released? Refer back up to the reaction. You can either write it out or you can use the symbols if you want to. Heat is endothermic, and a reaction that gives off heat is exothermic. So I'll come around and let you touch the test tube and note how it feels to touch. Touch the bottom of it. Does it feel cold or hot? And endothermic, how would it feel? Would endothermic feel hot or cold to touch? Endo. Would feel cold to touch. Exothermic would feel warm to touch. Based on what you felt. So now what we're going to test is, what I'm going to do with this is we have let this reaction work for a good bit. I don't think there's many more bubbles that are going to be produced. I'm actually going to take this liquid that's in here that the liver was sitting in there. Now I'm going to pour it into my test tube. No, I'm not drinking.
Test tube number 2.
Yeah, so this is test tube number 2. I poured the runoff from here into here. Try to get it all as much as I can. All right. All right, so now here's what I'm going to do. I'm going to take a new piece of liver and I'm going to put it in this runoff liquid, and let's observe what happens. So on a scale of 1 to 5, how would you rate the reaction of that? Okay. Original liver that I had, and I'm going to put some fresh peroxide into it, and let's see what happens. So here's the question that they ask you in the synthesis part. Is catalase, which is the enzyme that is in liver, is it reusable? Based on the two parts that we just did, is catalase reusable? So make me a sentence, a claim. Is it reusable? You can say catalase is a reusable enzyme. Tissues contain catalase. So for this is what we're going to do is you can see 4 different other things that we're going to compare with the liver because we know how liver reacts. The first one that we're going to look at is an apple. So I'm going to cut off a piece of an apple. It's an apple.
What kind of apple is it? Gala?
I think it was Gala, yeah.
Mm-hmm.
All right. And let's observe what happens with apple. You see that on the video? Piece of apple. All right. We'll repeat the same process with a potato.
Are these locally grown?
Obtained from Kroger. That ain't gonna fit.
So potato is test tube 4.
Yeah, we're in test tube 4, which is the potato. Need to see.
Apple's still not doing something. That's the apple.
The apple is number 3. Yeast. Like it was used to make bread, beer.
Yeast is test tube 5.
All right, number 5, yeast.
Oh, yeah. Yeah. That is 4.
So we are currently on test tube 6, raw chicken.
Oh man, I think I was gonna need the fall down. There we go. All right, so I have chicken liver is what we're using for our control, but let's see how it compares to raw chicken. Chicken muscle.
What's the difference between chicken liver and chicken muscle?
The liver is the organ within the chicken.
And the chicken is the...
This is the muscle.
Don't they always taste the same? Fried chicken? I never had liver. My dog.
View is, do all living tissues, because is an apple living?
No. Yes. No, it died.
It died. Is a potato living? Is yeast living? Is raw chicken, was it once living? Yes. Okay. Do all living tissues contain catalase?
So what do we have here? We have chicken liver, apple, potato, yeast, and raw chicken muscle.
To part C, we're going to look at the effects of temperature on catalase activity. All right, so what I have first, and I've already pre-boiled it, I've got boiled liver. All right, so I put it in some water and nuked the heck out of it. All right, so it's nice and tasty, yeah.
Taste it.
All right, so I'm gonna take it out of the water that it's been sitting in and boiled now, and I'm going to put it in our test tube.
So that's eatable?
So this is boiled liver,
That's eatable?
cooked liver. Yes,
Technically.
Don't eat it?
don't eat it.
Oh.
I mean, Mr. Scrack might eat it. He likes liver.
All right, this is test tube 7.
All right, so we're gonna look at if the liver has been boiled, and we add peroxide. Well, you can come up and see. You gotta.
Yep.
For test tube 8, I've got liver that has been chilling on ice in here, as well as peroxide. Yeah, they're both cold. So the liver itself is cold. You can see the frost around the condensation.
No, you know they have.
All right, and the peroxide is also cold. So cold liver and cold peroxide.
It could just be regular ice.
Ooh,
and bubbly. That shit's so like.
that's like a 3-pointer.
Y'all really giving points out here?
Yes, every point.
Oh, look, 3 points. That just like.
So think all the way back to when we did it with number 1. How does it compare to number 1?
Yeah, it gets a 3.
I did not boil the liver. I just took it and put it in warm water for a little while y'all were in here getting set up. So I've got warm liver and warm peroxide. So we're going to observe the same thing.
Oh, yeah. Oh, yeah, that was. Oh, my God. Oh, you're lame.
Next part, for part C, the synthesis. How does temperature affect the catalase enzyme? How does the temperature affect the catalase enzyme? Remember, you got 3 things to look at. The boiled liver with room temperature peroxide. Then we took cold liver, cold peroxide. And then warm liver, warm peroxide.